This is a quick revision of Topic 5 AQA GCSE Chemistry Energy Change. Reaction energy change. As chemicals store energy in them, when a reaction takes place, there is always a difference in the energy of the reactants and the product. So we have two scenarios here. The first one, if the energy of the reactant is more than the energy of the product, that means that energy must be given off during the reaction. And this is because the energy is not created or destroyed. It just moves around. This is called the law of conservation of energy. And now that means that the total energy of the reactants will equal the energy that was given off and the energy of the product. The second scenario is that when the reactant energy is less than the total energy of the product. In that case, that means that energy must be taken in from the surrounding. And again, the total energy of the product will equal the energy of the reactant and the energy that was taken in. So energy is not destroyed or created. This is called the conservation of energy. So there are two types of reactions here based on whether the overall reaction energy was given off or was taken in. The first one is when the energy of the reactants is higher than the energy of the product, and then energy must be given off in the form of heat to the surrounding. These reactions are called exothermic reaction. And there are several examples of this type of reaction like fuel burning or combustion, neutralization reaction, and many oxidation reactions. There are also applications and uses for these types of reaction. For example, the use of hand warmers. Hand warmers use exothermic oxidation of iron in air to release energy. Also, self-heating cans of chocolate and coffee use exothermic reactions between chemicals and their bases. The other type of reaction is called the endothermic reaction. In endothermic reaction, the energy of the reactant is less than the energy of the product. In this case, energy was taken in from the surroundings. Some examples of this reaction is the reaction between citric acid and sodium hydrogen carbonate, and also the thermal decomposition of calcium carbonate. So heating calcium carbonate causes it to decompose to give carbon dioxide and calcium oxide, and it uses energy or takes in energy for the reaction to complete. There are also applications and uses for this type of reaction, like sport energy bags. So the endothermic reaction will allow the bag to be instantly cooler without having to put them in the freezer. Reaction profile is a representation of the energy change during the course of the reaction. So chemical reaction can occur only when reacting particles collide with each other and with sufficient energy. So the sufficient energy that is needed here is called the activation energy, meaning that for the reactant to start the reaction, they need a minimum amount of energy to be supplied in order to allow for the bonds between the reactant to break. This energy is called the activation energy. And we can represent the energy change during the course of the reaction using the reaction profile. That will give us the relative energies of reactant and products, the activation energy, the overall energy change of a reaction. So to represent the energy profile of an exothermic reaction, we put the reaction progress on the x-axis and the potential energy on the y-axis. And then we know that for exothermic reaction, the energy of the reactant will be higher than the energy of the product. And then the reaction will proceed as follows. So at the beginning, there must be an increase in the reaction energy where energy must be supplied for the reaction to start until we reach a maximum point. The difference between the energy of the reactant and this maximum point is called the activation energy. Once the products start to form, then there will be a reduction in the energy until we reach the overall energy of the products. The difference between the energy of the reactant and the energy of the product is the overall energy change of the reaction. For an endothermic reaction, again, we have the reaction progress against the potential energy. The energy of the reactant now is less than the energy of the product. And we're going to represent the activation energy in the same way. So first, energy must be supplied for the reaction to start until we reach a maximum highest point here, which represents the activation energy. So the activation energy will be the difference between the energy of the reactant and the highest point. And then where energy will start to be given off, so the products are formed, and the difference in the energy between the product and the reactants, this is called the overall energy change. The energy change of the reaction. So why there is an energy change during the reaction? During a chemical reaction, energy must be supplied to break the bonds between the reactants, and energy is released when the reactant starts to react or when bond starts to form in the products. So the energy needed to break the bonds and the energy released when the bonds are formed can both be calculated from the bond energy. The difference between these two will give us the overall energy change. So the overall energy change is the sum of the energy taken in to break the bonds minus the sum of energy released to form bonds. And we have two scenarios here. The first one, if the energy taken in to break the bonds is higher than the energy released when the bonds are formed, then that means this is an endothermic reaction. And you can notice now that the difference between these two will be positive or will be plus, so this is an endothermic reaction. The second scenario, if the energy taken in to break the bond is less than the energy that is released when the bond is formed, so the overall difference will be more energy released. So this is an exothermic reaction, and the difference between these two values will be in the negative or the minus. This is the exothermic reaction. So we can use the bond energies to calculate the energy change. So let's take an example of a reaction between hydrogen and chlorine to make hydrogen chloride. The bond energies are as follows. So the bond energy between the two hydrogen atoms is 436 kilojoule per mole, between the chlorine is 242 kilojoule per mole, and for hydrogen chloride is 431 kilojoule per mole. To calculate the total or the overall energy change of the reaction, we need to calculate the energy needed to break the bonds, which will equal the energy difference or the bond energies for the hydrogen and for the chlorine. So when we add these two values, that will give us a total of 678 kilojoule per mole. For the energy that is needed to form the new bonds, now we have 2 moles of hydrogen chloride that has been formed. So this is why we multiply the 431, which is the bond energy for hydrogen chloride, times 2, because there are 2 moles, and the total for the energy that is released is 862. And now we need to calculate the overall energy change, which will equal the energy required to break the bonds minus the energy released by forming the bond, 678 minus 862, that will give us minus 184. So this is an exothermic reaction. Cells and batteries. So cells contain chemicals which react to produce electricity. An electrochemical cell will contain two different electrodes, and the two electrodes must be made out of metals like copper and zinc because metals conduct electricity. And we have an electrolyte, which is a liquid containing ions which will react with the electrodes. The electrodes are connected by a wire, and a charge that will allow the flow of the charge, and then the electricity is produced. The charge difference between the two electrodes will be generated, and that's what generate the electric energy. And we can use a voltmeter that can be connected to the circuit to measure the voltage of the cell. What is the difference between cells and batteries? Cells are made of two electrodes and an electrolyte, which allows the flow of the energy of the charge and create a potential difference between the two electrodes. While batteries are made up of several cells which are connected together. In this case, the difference in the potential energy between the different electrodes will be higher, so more electric energy is created or generated from batteries. There are two types of cells and batteries. The first type is the non-rechargeable cells and batteries. And this type of cells and battery depends on a certain chemical reaction, which are irreversible reactions. So once the reactant has been consumed completely, then the reaction will stop and then no more energy charge will be generated. So examples of these are the alkaline batteries, which are non-rechargeable batteries. There's also the second type, which is the rechargeable cells and batteries. In this case, they can be recharged because the chemical reaction are reversible and they can be reversed, and the reactants can be regenerated when an external electric current is supplied. One type of the rechargeable cells and batteries are the fuel cells. So fuel cells will use hydrogen as fuel and oxygen to produce electrical energy. A fuel cell is an electric cell that is supplied with fuel and oxygen or air and uses energy from the reaction between them to produce electrical energy difference. When when the fuel enters the cell, it will become oxidized and it will set up a potential difference within the cell. Hydrogen oxygen is one example of the fuel cell. Well, the fuel here is the hydrogen. The hydrogen oxygen fuel cell combines hydrogen and oxygen to give water and energy. The only product of this reaction is water. This is why the hydrogen oxygen fuel cell can be used in vehicle as a clean source of energy or a clean source of fuel, because the only waste product here is water. So how does the hydrogen fuel cell work? So hydrogen fuel cell is made out of two electrodes, and these two electrodes are made of graphite. So we have the graphite negatively charged electrode and we have the graphite positively charged electrodes. Graphite is used here because graphite can conduct electricity in the same way like metals. And then there is the electrical circuit where it's connected to the motor here that can actually make use of the energy or the electric energy to let the motor work. So the electrolyte in these cells is made out of or formed of potassium hydroxide, and potassium hydroxide is the source of the hydroxide ions. Hydrogen will be charged at the negatively charged electrode, and then it will diffuse through the negatively through that electrode. The hydrogen will be oxidized to give hydrogen ions, and the hydrogen ions will react with the hydroxide and it will lose electrons, and the electrons will flow through the circuit, creating a potential difference and generating electric current. This is an oxidation reaction, and we can represent the reaction between the hydrogen and the hydroxide because the hydrogen ions will react with the hydroxide to give water. So we can represent this as an overall reaction between hydrogen and hydroxide to give water and a release of 4 electrons as an oxidation reaction. Then we have oxygen, which will be charged at the positively charged electrode. At the positively charged electrode, the oxygen will diffuse, and once it diffuses, the oxygen will react with the water molecules in a reduction reaction to regenerate the hydroxide ions. The overall reaction between